Hello everybody. I believe we are on notes number 38 today. And today we're going to start chapter 6. It's a relatively short chapter. And today we're going to learn about radians. So when you watched the first YouTube video, you saw the explanation of the definition of a radian and how a radian is an angle such that if you have, whoa, that was a lovely circle. Let me try that again. If you have the center of the circle here and the radius is r, then the arc length is also r. And so the angle that is formed when you have the arc length equal to the radius is considered 1 radian. And we abbreviate it RAD. And we learned in the video that pi radians is equal to 180 degrees. Remember, first she said 2 pi radians is equal to 360 degrees because those are both one full rotation around a circle. So if we divide those by 2, we have pi radians equals 180 degrees. So we're going to use that as our conversion factor. And in fact, we can make a proportion. So the proportion would be pi radians over 180 degrees equals some number of radians over some number of degrees. So let's say you know the radians, you would plug that in and you would use x for the degrees. Or if you knew the degrees, you would plug that in and you would use x for the radians, and then you could solve for the one you don't know. So sometimes we're going to use the proportion, and sometimes we're just going to use fractions like you saw in the video where she took 2 pi radians equals 360, divided it by 2 on both sides, or then took that pi radians equals 180 and divided it by 2 on both sides and got pi over 2 radians equals 90 degrees. So sometimes we'll just use fractions like that. By the way, at the end of the video, she said that 1 radian equals 57 point blah, 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 blah degrees. I didn't like how she said that exactly because you should always say is approximately equal to, not equals, right? It's not exactly equal. Just approximately equal to. Okay, so when it comes to all of our common angles and the unit circle, we're going to use fractions. So let's work our way around the unit circle. These are all the common radian measures you should be able to find, and some of them you're going to memorize and others you're just going to work out as you go. So I think it's pretty easy to memorize that 0 degrees is equal to 0 radians. So let's start there. And 360 degrees is equal to 2 pi radians, so we can memorize that one. Half a circle, 180 degrees is equal to pi radians. And then when you divide that by 2, 90 degrees is equal to pi over 2 radians. And of course, if you need to pause so that you can draw a sketch of this, go right ahead and then resume as soon as you're ready. Okay, from here, let's take fractions of pi. So 30 degrees is 1/6 of 180 degrees, so it's 1/6 of pi, and so I normally call that pi over 6. 45 degrees is 1/4 of 180 degrees, and so in radians we would have 1/4 of pi, which we can call pi over 4. You can say this a number of ways. You can say pi over 4, you can say pi fourths, you can say 1/4 pi, they all mean the same thing. Same with like pi over 2, you could say pi over 2, you could say 1/2 pi, you could say pi halves, it doesn't matter. 60 degrees is 1/3 of 180, so we have 1/3 of pi, so that's pi over 3 radians. So all of the ones that we've filled in so far are really good ones to memorize, and you're going to use them more often than the others, and so you might just accidentally memorize them just because you're using them so much. Now let's work our way around to 120 degrees. 120 degrees is 2 times 60 degrees. So we have 2 times pi over 3, and that would be 2 pi over 3. Now let's do 135 degrees. 135 degrees is 3 times 45 degrees. So we have 3 times pi over 4, so that's 3 pi over 4 radians. 150 degrees. 150 degrees is 5 times 30 degrees, so we have 5 times pi over 6, so that would be 5 pi over 6. Let's go down to 210 degrees. 210 degrees is 7 times 30 degrees, so 7 times pi over 6 is 7 pi over 6. What you're going to notice on the bottom half of the circle is that the fractions are improper, like 7 over 6. The numerator is greater than the denominator. On the top half of the circle, the fractions were not improper. The numerator, like 2/3, the numerator is smaller than the denominator. The fractions are improper on the bottom half is because the number of radians is greater than 1 pi. So the fraction is going to be greater than 1. Okay, 225 degrees is equivalent to, 5 times 45 degrees. So that would be 5 pi over 4. 240 degrees is equivalent to 4 times 60 degrees. So that would be 4 times pi over 3, 4 pi over 3. 270 degrees is 3 times 90, so that would be 3 times pi over 2, which would just be 3 pi over 2. 300 degrees is 5 times 60 degrees, so that would be 5 times pi over 3, so 5 pi over 3. 315 degrees is 7 times 45 degrees, so that would be 7 times pi over 4, so 7 pi over 4. And 330 degrees is 11 times 30 degrees, so that would be 11 times pi over 6. So we call that 11 pi over 6. And you could do this for bigger angles too, like let's say for example 450 degrees. That would be 5 times 90 degrees, so that would be 5 pi over 2 radians. Often we don't write the word radian, we just leave it off, and if we leave it off we're implying radians. Now, sometimes you'll have angles that you want to convert, either from degrees to radians or from radians to degrees, and they might not be a common angle. So this is where we're going to use the proportion. Pi over 180 is equal to radians over degrees. So in number 1, we have degrees, and we're looking for radians. So we write pi over 180 equals x over 42. Now, it doesn't matter if you flip this proportion upside down, like 180 over pi equals degrees over radians. That works too. There's a lot of different ways you could orient this proportion and it's still true. Next thing we want to do is cross multiply. So we have 180x equals 42 pi. And then divide both sides by 180. So x equals 42 pi over 180. And then we're going to reduce the fraction, but what you can do if you're using your calculator to reduce the fraction is just put 42 over 180 in there. So 42 divided by 180, and then press math, change to fraction is your first option, press enter. So that fraction reduces to 7/30. Notice I did not put the pi in there, just the numerical part, just the rational part. So this is 7 pi over 30. Okay, for the next one, we're given the radian measure and we want to find the degree measure. So we'll start with our proportion. Pi over 180 degrees equals pi over 10 radians over x degrees. And then we can cross multiply and we have pi times x equals 180 times pi over 10. So you can divide both sides by pi. And then what you have left is x equals 180 over 10, so x is 18 degrees. Now you could actually do that one without the proportion if you just think of pi over 10, pi radians over 10 as 180 degrees over 10. So all you do is substitute 180 degrees in place of pi. That would be faster. And problem number 3, we have a degree measure and we're going to find the radian measure. Notice the degree measure is pi degrees. So typically if we see pi, it generally means we're working with radians, but it doesn't have to. Just think of pi as any number, like 2 or 3 or 5. So we're going to convert that to radians. Let's use our proportion. Pi over 180 equals radians, we don't know, over degrees, pi. Cross multiply, 180x equals pi times pi, which is pi squared. Divide by 180, and x is pi squared over 180. Notice that I'm just leaving all of these exact. I'm not using 3.14, that's not the exact value of pi, And it doesn't say approximate, so if it doesn't say approximate, just leave everything exact. Okay, speaking of exact, you know how we did exact values with degrees like sine of 30, tangent of 90, cosecant of 135, and so on? Well, we can do all of that with radians as well. And when you get to calculus, you're going to be using radians by default, not degrees, so it's good to practice this. So here's how we do it. The first thing I like to do is convert my radian measure into degrees. So if I see sine of pi radians, I know that it means sine of 180 degrees. Then I just do that problem the way I always have. Unit circle, here's 180, that's the point -1, 0. Sine is the y-coordinate, so the answer is 0. Number 5, cosine of pi over 4. Well, pi over 4 is the same as 45 degrees. Pi over 4 radians equals 45 degrees, so we make that conversion, and then we can draw our reference triangle with a 45-degree angle, sides 1, 1 square root 2, and the cosine is 1 over square root 2. Rationalize that, and we get square root 2 over 2. Tangent of 2 pi over 3. Let's convert 2 pi over 3 into degrees. So we know that pi is 180, divide that by 3, and now we have 60. Multiply that by 2, and now we have 120. So this is tangent of 120 degrees. Let's draw our reference triangle. Here's 120, so this is 60. So we have a 30, 60, 90. Put your square root 3 on the long leg, your 1 on the adjacent, and your 2 on the hypotenuse. Tangent is opposite over adjacent, so that would be negative square root 3. Secant of 3 pi over 2. So pi is 180. Divide by 2, we get 90. Multiply by 3, we get 270. So this is secant of 270 degrees. Unit circle. This point down here at 270 has coordinates 0, -1. Secant is the reciprocal of cosine, and the reciprocal of 0 is undefined. Cosecant of 11 pi over 6. Pi is 180. Divide that by 6, we get 30. Multiply that by 11, and we get 330. So we're finding the cosecant of 330 degrees. Draw the reference triangle. This is 330. So this in the triangle is 30. So we have a 30, 60, 90. Opposite of 30 is the 1. Put a negative on it to go down. And then the cosecant is the reciprocal of sine. So we would do hypotenuse over opposite and get -2. And cotangent of 7 pi over 4. Pi is 180, divide that by 4, we get 45, multiply that by 7, and we get 315. So this is cotangent of 315 degrees. Draw the reference triangle, quadrant 4, this is 315, so this is 45. So we have 1, 1, square root 2, put the 1, a negative on the 1, showing we're going down. And then cotangent would be adjacent over opposite, so our answer is -1. Okay, so we're just adding a step to what we already knew how to do. Now, typically in this lesson, if we were at school, I would also teach you how to find the arc length and how to find the area of a sector. But because we're not at school and we have to cut things down a little bit and shorten them, I'm going to skip those. But if you're interested in learning about it, you can find it in your book, page 561 to 564. Okay, your assignment does include some evens. So what I'm going to do is make a video of the solutions, and that way if you're stuck you can watch the video, but at the front of the video I'm going to include all the answers to all the odds and evens, so you can just glance at that and see if you get your answers right. Thanks everybody.